Hello friends, in the previous video, we discussed about the data structures that we are going to use in our order book. So we discussed that we are going to maintain the buy price levels and the sell price levels using two priority queues, in which the key would be the price double itself. And the third data structure that we discussed was using a map in which the price is the key and a doubly linked list. Doubly linked list which will be containing all the orders in the basis of time priority, which means that on the head at the head the order with the best time priority at the same price level, right? Just remember it's the same price, but a better time priority that would be placed at the head of the order list, and subsequently whatever the next elements which would be there in that list that would be having in the time priority in the descending order, starting from the head having the highest time priority and going to the tail, it would be the priority would be in the descending order. So just for this doubly linked list, right? I mean, last video I discussed that. If I just open it, so in this I actually created my own implementation of doubly linked list, in which I created a node in which each data element would be an order and a previous and next links to the nodes. And here I actually added all those methods myself. But in the real world scenario, when you are asked in an interview, it might be quite tedious and tough to implement this whole doubly linked list on your own and covering all the edge cases, right? The only difference that we are doing it, that we are also maintaining two extra parameters, two extra like fields of this properties of this order list is we are maintaining the size, the total size at this price level, and also the total volume which is available at this particular price level. Besides that, it's all the doubly linked list that we have implemented by our own. As mentioned, that is, I mean, if you find it very difficult to implement on its own, it's better to use the Deque, which is already available in Java. So Deque is the same as doubly linked list, in which to be specific, I would be using array Deque, and it can be easily used and replaced in my current code. So that we don't need to use a doubly linked list by our own, but we can directly use the Deque. And then we can also maintain this size and total volume. So for all these add head and add tail methods, we can just call the methods which are already available in our Deque class in Java. So here in my implementation, you can see that I have commented out this code in which you can easily simply replace this order list with Deque. The difference, as mentioned, that Deque with order list with Deque would be using the Deque class directly from the Java API. So now look at add order method. So when we receive a new order, first of all, I mean, we'll always check that whether the order has been received previously or not. This can be done by checking the order ID, which is always unique. And we are maintaining this in our order cache as a map in which the key is the order ID and the value is the actual order. So definitely, I mean, we have to check this first. That this is the first time we are receiving this particular order with this particular ID. And then first of all, we try to match the orders, which I will cover in the next video. But let's go on with this. If the order is not filled or there is no any like matching opportunity, so we have to add this order to our order book. So this will be coming to our add order to order book, in which we will go to this method. Now let's discuss in details about this method. So first of all, we will maintain our cache that we are going to put the key as order ID and the value as an order. And now, as we discussed that we have got three data structures in our case. To be precise, two data structures for one side, buy or sell. So first is that if the order is of buy, then we are going to add it to our priority queue, buy price levels dot add price. Remember that we are maintaining this priority queue. So if I just go back here, so we are maintaining priority queue for the price levels for both buy and sell orders. So let's go back. So whenever we call this add method on a priority queue, the time complexity is O of log n. So this is what we are doing now. So if there's a price already available there, if you want to add that, then also it would be the same O log n level of time complexity. Now the second data structure that we discussed was we need to add to our map, in which the key would be the price and the value would be a doubly linked list or a Deque. So this is what we are doing. Order at price, compute if absent. So compute if absent means that if this key or this price is not available at the moment, then we'll create a completely new key value pair in which the price would be mapped to a totally new order list, and then we will add to the tail of that linked list. Now this is important. This part, add tail, because so there are two scenarios possible, right? Suppose if we are trying to add it to our Doubly Linked List and the price is already available. So let me show in a map first. So let's suppose that we have got a buy order of price 20.2. Okay. So first of all, we added into a priority queue of like buy levels, which having log n. 20.2 is already available there. So there would be no changes as such. But now we have already got one order entry, order 1, which is at the same price level, and it was already inserted at 908. And now we have got a time at say 9:10 or 9:15, whatever, which is greater than 908. That's why we have to append this new order here as a tail of it. So here we will insert our new order. So here what it means is that because all our order books are based on the price and time priority, price we have already found based on the priority level, and the time priority, any order which is already placed near the head, that is already having the better time priority. So the order which I have received now, it means that the time is greater than whatever the time it was inserted before. So after this only we are going to receive at greater than 908 time this point. That's why we are always adding to the tail. So that's why I mentioned that whenever we want to add any order, we are always going to add it to the tail of our Doubly Linked List to maintain the time priority. So adding it to the tail in both the scenarios, when the price is not present, then we are always going to add tail. Or if the price is already present in our Doubly Linked List map, then also we are going to add it to the tail. It always maintains the time priority. So this is all that we need to do in our adding an order or adding an unfilled order to our order book. So now let's talk about the total time complexity, right? As we have seen that putting into order cache, put method is always O1. So this part is O1. Adding it to a priority queue is always O log n. And now for adding it to our map here, even though we are having the value as a Doubly Linked List, still the addTail method, it's time constant. So this is also going to be O1. So the overall time complexity would be O1 plus O log n plus O1. So it means that it would be O of log n. So using our new data structure in which we have the priority queue formatting our price and adding and having a Doubly Linked List as a map value at the same price level, would be having the overall time complexity of O of log n in the worst case. So this is much of a better design as we discussed before with our linked list and just plain priority queue. This 2D data structure is much better in terms of performance while adding it to order book, and it can also scale well. We can scaling means that we can add as many orders to our linked list, this linked list at the same price level. And we can also try to like parallelize it by making 4 different stocks for different order books, so that this is a much better design as we discussed before. So in the next video, we'll see as we discussed that we skipped the matching of the orders part. So we'll cover that in the next video.